All right, let's jump right into this finals prep for green computing. We are going to lock down the core concepts today by directly applying them to analytical, scenario-based practice questions. Because, let's be honest, to ace this exam, you really need to know how to translate the theory into actual, real-world engineering and procurement decisions. So, this explainer is designed as a highly focused study guide, walking you through the exact types of scenarios you're going to face.
Here's our battle plan for today. We're covering the embodied carbon trap, analyzing greenwashing, decoding hardware certifications, and finally, doing the actual math on both power efficiency and total cost of ownership.
Starting off with Section 1, the embodied carbon trap.
Take a look at this life cycle assessment breakdown. It is actually kind of wild. A staggering 75% of a smartphone's carbon footprint is entirely locked in during manufacturing. That's before you even open the box. Only 17% comes from the use phase, actually charging and using the thing. So the embodied carbon, the CO2 emitted just to dig up the materials and build the device, literally dominates the equation.
So, let's test this with a scenario straight from the practice quizzes. For a smartphone used for 3 years, roughly what percentage of its total lifetime carbon footprint comes purely from making it?
Well, if we walk through the logic, we know phones sip power, right? We're talking maybe 3 to 5 watts to charge, but they require incredibly intense material extraction for all those rare earth metals. So the answer sits right around 70 to 80%. And what that means for us is that your absolutely most sustainable action isn't buying a slightly more efficient phone, it's just keeping your current phone longer. If you spread that massive chunk of manufacturing carbon over 4 years instead of 2, you literally halve your per year impact.
Moving right along to Section 2, let's talk about analyzing greenwashing scenarios.
Think of this one like a puzzle. A company puts out a press release claiming a massive 70% lower carbon footprint for their new hardware. Sounds great, right? But then you dig into the fine print and realize they achieve this mostly by planting trees, not by actually changing how their product is manufactured. What specific greenwashing sin are we looking at here?
Yup, this perfectly illustrates the hidden trade-off sin. The headline number? Technically true because of the offsets, but it totally masks the reality that the actual factory is churning out the exact same emissions. True sustainability is about reducing emissions at the source, not just buying carbon indulgences after the damage is done.
Which brings us to Section 3, decoding hardware certifications.
Okay, here's your rapid-fire cheat sheet for the Big Five. You gotta memorize these because they handle totally different things. Energy Star is all about operational efficiency. EP, that's your full life cycle rating. TCO Certified adds strict social requirements into the mix. 80 Plus is hyper-focused on your power supply, and ROHS restricts nasty stuff like lead and mercury.
Let's do another practice question. Which of those labels actually looks out for the workers on the assembly line? If an IT buyer needs to guarantee supply chain traceability and fair labor conditions, which certification do they absolutely need to demand?
If you guessed TCO Certified, you hit the nail on the head. It's the absolute gold standard for organizations that need strict ESG and social compliance, because unlike EPEAT or Energy Star, TCO uniquely forces companies to prove fair working conditions, minimum wage compliance, and conflict mineral traceability right alongside the environmental stuff. It's the whole shebang.
Let's jump into Section 4, the power efficiency math.
All right, roll up your sleeves. We're doing the hard math now. Here's the setup. You've got a 400-watt server running a 200-watt IT load. We need to find the exact amount of wasted power between a basic power supply sitting at 78% efficiency and an 80-plus gold certified one at 92% efficiency. How do we figure out the actual power being drawn from the wall?
Let's break it down. To get the wall draw, you just divide the IT load by the efficiency decimal. So, for the basic unit, 200 watts divided by 0.78 gives us 256 watts pulled from the wall. For the gold unit, 200 divided by 0.92 is 217 watts.
Subtract those, and we get a 39-watt difference per server. Now, 39 watts might sound like peanuts, but let's scale it up. If you've got a 100-server data center running 24/7, you're looking at over 34,000 kilowatt-hours saved a year. That's over $3,000 in wasted electricity just vaporizing into thin air. Plus, you've got to pay to cool that 39 watts of waste heat. Paying a little extra for that gold PSU pays for itself incredibly fast.
Finally, Section 5, calculating the total cost of ownership.
This is the ultimate procurement showdown. Product A looks like a steal at $350 up front,
but it only lasts 3 years. Product B gives you sticker shock at $480, but it lasts 5 years, it's EP8 Gold, and its Energy Star rating saves you $25 a year in power. How do we mathematically prove which is actually the better deal?
The secret here is you have to normalize the lifespan. You can't compare 3 years to 5 years. So we scale product A's $350 cost up by 5/3 to match a 5-year life cycle, and boom, its true cost balloons to $583. For product B, we just subtract 5 years of that $25 energy savings from the upfront cost, dropping its true cost $355. Look at that. You are saving a massive $228 per unit by going with the certified sustainable product B. The upfront sticker price is just an illusion. Total cost of ownership is the only math that matters.
And that brings us to what we call the procurement multiplier. As an IT buyer or engineer, your one little specification choice scales across an entire fleet. If you write EP8 Gold required into a tender for 500 laptops, you are locking in massive sustainability and financial wins for years to come.
So, you've worked through the scenarios, you've crunched the math. The only question left is, how are you going to use this? When you sit down to write your very next hardware tender, what specific certifications and lifespan requirements are you going to demand? Because honestly, that is where real green computing actually happens.